Hello, welcome to In 5 Minutes. The next question tells us to find VTH and RTH. That means we need to replace the circuit shown in the red box with a single voltage source in series with a single resistance. Here you can see there are two sources, plus 2 volts and minus 5 volts, and two resistances 35k and 20k. Which principle we use? We use superposition theorem and replace. That is, we'll consider first 2 volt, ground minus 5 volts, find the equivalent voltage. Then we consider minus 5 volts, ground 2 volts, and find the equivalent voltage. That will give you the total voltage, and by parallel combination of both the two resistances, that will give us the total resistance. Now how to go about it? Consider the plus 2 volt voltage source and ground the 5 volt voltage source. What has been done? The minus 5 volt voltage source has been grounded and we are considering only plus 2 volts. So because of plus 2 volts, we will find the VTH dash by potential divider principle. You can find voltage VTH dash. What will be the equation for VTH dash? Voltage across the resistance. That means we find VTH dash with respect to ground, and that resistance will always come in the numerator. So you will have 20 into 10 raised to 3 in the numerator. Total resistances in the denominator, that is 20 into 10 raised to 3 plus 35 into 10 raised to 3 multiplied by the total voltage. Now you have total voltage as 2 volt. This will give you VTH dash as 0.727 volt. This is how we have found the half part of finding VTH dash. Now what we'll do, we'll ground 2 volts and we'll consider minus 5 volts. Now in this case you can see over here we have grounded the 2 volt voltage source and we are considering the minus 5 voltage source. Now what will be the equation for VTH dash? Again by potential divider principle you can find VTH double dash. VTH double dash will be, now which resistance will come in the numerator? Which is grounded. The other terminal of the resistance is grounded, that will come in the numerator. Why? We measure VTH dash always with respect to ground. So we'll have R1 upon R1 plus R2 multiplied by now minus 5. So value of R1 is 35 into 10 raised to 3. Value of R1 is 35 into 10 raised to 3 and value of R2 is 20 into 10 raised to 3 multiplied by minus 5. This will give you the value as minus 3.18 volt. So we have got VTH double dash. Right, now we can find total VTH. How to find total VTH? By superposition theorem. What we'll do, VTH will be VTH dash plus VTH double dash, which is 0.727 volts minus 3.18 volt. That will give you VTH as minus 2.45 volt. Once you have found VTH, you can find RTH. How to find RTH? You have two resistances, R1 and R2. Value of R1 is 35 kilo ohms and value of R2 is 20 kilo ohms. For finding the resistance, we ground the voltage source, and here at this point we need to find RTH, which implies your 35 kilo ohms and 20 kilo ohms will come in parallel, across which we need to find RTH. Equation for RTH will be 35 kilo ohms in parallel with 20 kilo ohms. How we find 35 in parallel with 20? 35 into 10 raised to 3 multiplied by 20 into 10 raised to 3 whole divided by 35 into 10 raised to 3 plus 20 into 10 raised to 3. This will give you the value of RTH as 12.727 kilo ohms. Finally, you can just show the diagram as a single voltage source, then in series with a resistance, you can say RTH. Then you have your transistor resistance RE. Here you have resistance RC. The supply voltage given as plus 10 volts. You have RC as 0.8K, RE as 0.5K. Now instead of the two resistances and two voltage sources, we have found a single voltage source VTH, whose value we have got. How much is the value for VTH? Minus 2.45 volts RTH we have found as 12.727 K, and this voltage is minus. This is how we have reduced the given circuit diagram into a single voltage source in series with a single resistance.